For centuries, the moon has held a special place in our imaginations. It's the one constant in our night sky, a silent companion to Earth, distant yet so close. We look up at it with wonder, but few understand the incredible challenges it takes to actually reach and land on its surface. To make this journey a reality requires more than just ambition or the desire to explore. It demands technology, precision, and an intimate understanding of the forces that govern space. Landing on the moon isn't just a matter of flying up and touching down. It is, in fact, one of the most complicated and dangerous undertakings ever conceived by humankind. Despite being relatively close in terms of distance, only about 238,855 miles away, getting there and safely landing involves overcoming hurdles that have tested the limits of human ingenuity and perseverance. So, why is landing on the moon so hard? First, we need to understand the environment of the moon itself. The moon may be our nearest celestial neighbor, but it is far from hospitable. Unlike Earth, the moon has no atmosphere, no protective air layer to shield astronauts from the sun's radiation, no cushion to slow down a spacecraft during descent. In fact, this lack of atmosphere introduces a host of problems that would seem insurmountable to anyone unfamiliar with the challenges of space. Without air, the moon's surface experiences extreme temperature fluctuations. The daytime temperature can soar to over 250 degrees Fahrenheit, hot enough to melt metal, while at night, it plummets to a bone-chilling minus 250 degrees Fahrenheit. This vast temperature swing is enough to challenge even the most advanced spacecraft. Materials must be engineered to survive these extremes, from the delicate electronics to the life support systems necessary for human survival. But that's just the beginning. Landing on the moon requires a careful, controlled descent, one that we cannot rely on atmospheric drag or parachutes to slow down. Every bit of speed must be precisely controlled by rocket thrusters, and there is no margin for error. You might think that the moon's weaker gravity would make landing easier. After all, it's only about 1/6 that of Earth's. But here's the catch. The weaker gravity creates a completely different set of challenges. Because the moon's gravity is so much less than Earth's, a spacecraft can't rely on the familiar freefall method we use to land on Earth. On Earth, gravity and the atmosphere work together to slow down a descending object. But on the moon, without an atmosphere to provide that cushion, a spacecraft's descent must be meticulously controlled. Imagine trying to land on a surface that offers no feedback, no wind, no drag, only the pull of gravity itself. The descent is slower, and that means there's less time to correct mistakes. Every movement must be calculated and exact, from the altitude and descent speed to the orientation and final positioning. Now, consider the surface of the moon itself. Far from being a flat, barren wasteland, the moon's surface is dotted with jagged rocks, craters, and steep ridges. Unlike Earth, where we have a diverse landscape, but also a variety of safe landing areas, the moon presents a treacherous topography. A spacecraft might have to deal with unexpected obstacles, like craters several feet deep or massive boulders that could make a landing site unsafe. During the Apollo missions, for example, astronauts had to adjust their descent in real time to avoid landing in a crater or on uneven ground that might have caused the lander to tip over or even destroy the mission. A miscalculation, even by a few degrees, could mean disaster. In fact, during Apollo 11, Neil Armstrong famously had to take manual control of the lunar module when he realized that the automated landing system was steering him toward a crater. He had only moments to find a safe patch of ground, all while maintaining control of a spacecraft hurtling toward the lunar surface. Landing on the moon demands perfect precision, and it's not just about knowing where to land, but how to get there. The spacecraft has to slow down from high speeds in a vacuum, adjust its trajectory, and ensure the landing gear is deployed and functioning properly, all at exactly the right moment. During the Apollo missions, astronauts used a combination of onboard computers and visual cues to help guide them. These systems, while groundbreaking at the time, had their limitations. The lunar module's computer system could only process a fraction of the information that today's systems can handle, and the astronauts had to rely on their own instincts to make split-second decisions about how to adjust their descent. For example, during Apollo 11, Armstrong had to adjust the lunar module's descent in mid-flight. He did this manually, using a joystick to make corrections. As the spacecraft descended, the system had misjudged the terrain, and Armstrong had only a few minutes to find a clear spot. The margin for error was razor thin. Over the decades, technology has evolved, but the basic principles of lunar landing haven't changed. The need for precision, durability, and robust systems remains as critical today as it was during the Apollo missions. But modern spacecraft are equipped with far more advanced technology. Today, spacecraft can rely on high-resolution radar, autonomous navigation systems, and much more powerful computing systems to manage the complexities of landing. For instance, modern landing modules like those being developed for the Artemis program will use state-of-the-art guidance and navigation systems that can autonomously adjust their descent, making the landing process far more accurate than before. These systems can calculate the ideal descent trajectory in real time, adjusting thrust and speed to avoid obstacles and ensure a smooth landing. But even with these advanced technologies, the moon remains a formidable opponent. Every time we attempt to land, we're up against the harshness of the environment and the unpredictability of the lunar surface. Landing on the moon is a monumental task, but it's only half the challenge. Once the mission is complete, astronauts or equipment must return to orbit and eventually Earth. The return journey involves launching from the moon's surface against its weak gravity, but without the help of an atmosphere. No parachutes, no drag, no cushion. The spacecraft must generate enough thrust to break free of the moon's pull and reach lunar orbit. Once there, a rendezvous with the return vehicle is necessary before the journey back to Earth can begin. This re-entry process requires even more precision and accuracy, and it must account for the moon's weak gravity, which makes it harder to establish a trajectory for a safe and controlled ascent. Despite these enormous challenges, we are preparing to return to the moon. The Artemis program is set to carry astronauts back to the lunar surface by the mid-2020s, aiming to establish a sustainable presence there. New technologies, many of them tested in robotic missions, are making lunar landings safer and more reliable than ever before. The innovations we've seen, from autonomous landing systems to advanced surface rovers, will lay the groundwork for humanity's future presence on the moon and beyond. The moon may still present challenges, but it also holds the key to a deeper understanding of our solar system and the first steps toward future missions to Mars and other distant worlds. As we prepare to land once again, we can look to the future with confidence, knowing that every lesson we learn from the moon will take us further into the cosmos. The moon may seem like just a distant object in the night sky, but for those who dare to venture to its surface, it is a test of skill, perseverance, and human ingenuity. While landing on the moon is not easy, it is a challenge we continue to meet, and it will remain one of humanity's greatest triumphs. The road ahead is filled with new challenges, but as we look toward the stars, we know that with each mission we undertake, we are one step closer to understanding the cosmos. And with each step, the moon will remain a symbol of what we can achieve when we reach for the impossible.